The date is November 22nd, 1989. A phone rings at Beale Air Force Base in Northern California. The voice is calm. One instruction: stand down. Permanently. The SR-71 Blackbird program is over. 24 years of operational service. More than 53,000 flight hours. Missions over North Korea, Vietnam, Cuba, Libya, and the Soviet periphery. No aircraft ever intercepted. Not once. Over 24 years, surface-to-air missiles were fired at SR-71s approximately 4,000 times. Every single one missed. At Mach 3.2 and 85,000 feet, the aircraft was simply faster than anything sent to destroy it. This is History Unclassified. Subscribe now. This one goes fast. The year is 1957. The Soviet Union deploys the S-75 Divina surface-to-air missile. Service ceiling, 82,000 feet. The U-2 spy plane flies at 70,000 feet. The margin is gone. The U-2's days are numbered. CIA Director Allen Dulles commissions a replacement study that same year. The requirement is simple on paper and almost impossible in practice. Fly higher than any missile can reach. Fly faster than any interceptor can chase. Do both at the same time. The study lands on one desk. Clarence Leonard Kelly Johnson, chief designer at Lockheed Skunk Works. Johnson had already built the U-2. He did not design ordinary aircraft. In November 1959, the CIA approves project codename OXCART. 11 engineers, one classified facility, a sustained cruise speed of Mach 3.2. That is 2,455 miles per hour. At that speed, the airframe skin heats to over 316 degrees Celsius. Standard aluminium fails. Standard fuel boils. Standard tires shred on landing. Johnson needs a material that barely exists in production. He finds one: titanium. In 1960, 93% of the A-12 airframe is constructed from titanium alloy. The United States cannot produce enough domestically. The primary global source of the required grade is the Soviet Union. The CIA purchases it through covert front companies. America builds its most classified aircraft using Soviet raw materials. The Soviets never know what they are supplying. The first A-12 is delivered to Groom Lake on February 26, 1962. It flies for the first time on April 26, 1962, on time, under budget, 30 months from approval to flight. But the A-12 is not the final aircraft. The Air Force wants something bigger, something that can carry more sensors, fly longer missions, operate globally. A new requirement is written. A new designation is assigned: SR-71. The SR-71 is longer than the A-12, heavier, more capable. It first flies on December 22, 1964. The most advanced aircraft the world has ever seen. And almost no one knows it exists. What comes next is where the story gets truly extraordinary. The SR-71 is not painted, it is coated. A special black ferret paint that absorbs radar energy rather than reflecting it. The color is functional. It also radiates heat from the airframe during sustained high-speed flight. Length, 107 feet, 5 inches. Wingspan, 55 feet, 7 inches. Maximum speed, Mach 3.3. Operational ceiling, 85,000 feet. Range, 3,200 miles unrefueled. At Mach 3.2, the SR-71 covers 1 mile every 1.9 seconds. It can photograph 100,000 square miles of Earth's surface in 1 hour. The two Pratt & Whitney J 5.8 engines each produce 32,500 pounds of thrust in full afterburner. At cruise speed, they function less like jet engines and more like ramjets. The aircraft's own speed feeding compressed air into the combustion cycle. The fuel is JP7, a custom formulation with a flash point so high it cannot be ignited by Mach at sea level. The engines require a chemical injection system called triethylbutane just to start. The aircraft leaks fuel on the ground, deliberately. The titanium panels are manufactured with small gaps because at operating temperature the metal expands enough to seal them. Before reaching that temperature, the aircraft drips JP7 onto the tarmac. Every crew chief knows this. It is considered normal. The pilot and reconnaissance officer fly in full pressure suits. At 85,000 feet, the atmosphere outside is less than 1% of sea level density. An unprotected human loses consciousness in seconds. The SR-71 is publicly acknowledged on February 29, 1964. President Johnson announces it in a press conference. He calls it the A-11. He gives incorrect performance figures. The real aircraft is more capable than anything he describes. The misdirection is deliberate. 32 SR-71As are built between 1964 and 1968. The first operational squadron is the 1st Strategic Reconnaissance Squadron at Beale Air Force Base. Crews train for a minimum of 12 months before their first mission. The first operational SR-71 mission is flown on March 21, 1968, over North Vietnam. North Vietnamese radar tracks it. SA-2 missiles are fired. The SR-71 is already past the target before the missiles reach altitude. That pattern repeats for 2 decades. Radar detects. Missiles launch. The aircraft is gone. At Mach 3.2, the outside air temperature against the forward fuselage reaches 427 degrees Celsius. The cockpit window is warm to the touch from the inside. The entire aircraft glows a dull cherry red, visible to the naked eye from the ground. At 85,000 feet, the sky above is black. The curve of the Earth is visible without any optical aid. Every mission is a world record that cannot be officially claimed. Every flight is classified, but the missions are real. The targets are real, and what the SR-71 brings back is about to change how America sees its enemies. The SR-71 does not carry weapons. It carries cameras, signals intelligence receivers, infrared sensors, side-looking radar systems. Its only defense is speed. A standard SR-71 mission profile runs between 3 and 4 hours from takeoff to landing. The aircraft requires aerial refueling within the first 30 minutes because the tanks cannot carry enough JP-7 for the full mission. The tanker, a KC-135Q specially modified to carry JP-7, meets the SR-71 at subsonic speed at low altitude. The SR-71 slows to refueling speed. The crew takes on fuel, then the aircraft climbs back up, accelerates through Mach 1, through Mach 2, and levels out at Mach 3.2 at 85,000 feet. The acceleration phase alone covers several hundred miles. Once at cruise altitude and speed, the reconnaissance systems activate. A single pass over a target area can cover a strip of terrain 100 miles wide. The cameras resolve objects less than 1 foot across from 15 miles above the ground. The film canisters are recovered after landing, processed within hours. On the desk of an intelligence analyst the same day. Between 1968 and 1989, the SR-71 flies operational missions over North Korea, Cuba, Vietnam, the Middle East, Libya, and along the periphery of Soviet airspace. It never enters Soviet airspace directly. The cameras are angled obliquely. It photographs Soviet territory from international airspace at a distance of up to 100 miles. The Soviets know it is there. They track it every time. They cannot stop it. In 1981, Soviet Air Defense Command formally documents a standing order to intercept SR-71s operating along the Baltic and Arctic corridors. MiG-25 Foxbats are scrambled on multiple occasions. The fastest interceptor in the Soviet inventory cannot reach the SR-71's altitude at the speeds required to intercept. One Soviet pilot later stated in a post-Cold War interview that he was given a simple instruction before each scramble. Climb as fast as possible. Fire everything you have. The pilot knew before takeoff the mission would fail. The SR-71 crew often does not know a scramble has been ordered until the debrief. At Mach 3.2, there is no threat that requires a reaction within the time frame of a mission. By 1986, the program has logged over 11,000 operational sorties. 17 aircraft are lost to mechanical failure and accidents across the life of the program. Not one is lost to enemy action. In April 1986, the SR-71 flies post-strike reconnaissance missions over Libya, following Operation El Dorado Canyon. The missions are flown from Mildenhall Air Base in England. The round trip covers over 12,000 miles. Each mission requires multiple aerial refuelings. The photography produced goes directly to the White House within hours of landing. By this point, the SR-71 has become something beyond an aircraft. It is an instrument of intelligence that no adversary can neutralize. But inside the Pentagon, a different conversation is forming. The question is not whether the SR-71 can be stopped. The question is whether America still needs it. The argument against the SR-71 begins in the early 1980s, not from adversaries, from inside the U.S. government. The case is financial. Each SR-71 costs approximately $200,000 per flight hour to operate. The program as a whole costs over $300 million per year at its peak. Satellite reconnaissance has matured. The KH-11 Kennan satellite, first launched in December 1976, returns near real-time imagery from orbit. It does not require a crew. It does not require JP-7. It does not require KC-135 tankers. The argument from the intelligence community is that satellites can cover the same targets for a fraction of the cost. The SR-71 community pushes back. Satellites operate on fixed orbital paths. An adversary who knows the schedule can hide activity between passes. The SR-71 can be redirected to a target within hours. It can overfly a crisis zone on the same day the order is given. In 1979, when Soviet forces move into Afghanistan, SR-71s are retasked within 24 hours. Imagery of Soviet force dispositions reaches Washington the same day. No satellite could have matched that response time. In 1982, during the Falklands conflict, SR-71 missions are considered, but ultimately not authorized. The political complications of operating near Argentine airspace from a British base are assessed as too significant. The debate continues through the mid-1980s. In October 1987, the Senate votes to defund the SR-71 program. The Air Force leadership supports the decision. The intelligence community does not. The Director of Central Intelligence argues formally that the SR-71 provides a capability that satellites cannot replicate. The argument is noted. The decision stands. On November 22, 1989, the last operational SR-71 mission is flown. The aircraft lands at Beale. The engines are shut down. The program is officially closed. 9 SR-71s are transferred to museums across the United States. One goes to the Smithsonian. One goes to Wright-Patterson. Others go to Beale, Barksdale, Lackland, and Robbins. Then something unexpected happens. In 1990, Iraq invades Kuwait. U.S. forces deploy to the Gulf region. Intelligence requirements surge. Satellite coverage is stretched. The argument the SR-71 community had been making for 3 years becomes suddenly relevant. In 1994, Congress votes to reactivate 3 SR-71s. The Air Force complies without enthusiasm. 2 aircraft are returned to operational status. They fly again. But the reactivation is short-lived. The Air Force continues to resist the program on cost grounds. In 1997, the SR-71 is finally and permanently retired. The last flight of an SR-71 in service takes place on October 9, 1999. It is a retirement flight to the Air Force Flight Test Museum at Edwards Air Force Base. The aircraft that lands that day had never been intercepted, never shot down, never defeated by any system any adversary ever deployed against it. It was retired by a budget decision, not by an enemy. The SR-71 holds records that have never been broken. On July 28, 1976, SR-71 serial number 17958 sets the absolute airspeed record for an air-breathing aircraft, 2,193.167 miles per hour, Mach 3.3 at altitude. The same aircraft sets the absolute altitude record for horizontal flight on the same day, 85,069 feet. Both records still stand. No aircraft flying today has surpassed either the SR-71 also holds the record for the fastest coast-to-coast flight across the United States. On March 6, 1990, during its retirement ferry flight, SR-71 serial number 17980 flies from Los Angeles to Washington, D.C. in 67 minutes and 54 seconds. A commercial flight covers the same distance in 5 hours. The crew of that flight, Lieutenant Colonel Ed Yielding and Lieutenant Colonel Joseph Vida, land at Dulles International Airport and walk the aircraft to the Smithsonian National Air and Space Museum. It is still there. Across 24 years of operational service, the SR-71 flew 53,490 hours, completed 3,551 operational sorties, photographed targets in 29 countries, flew along the borders of the Soviet Union more than 1,000 times, was fired upon by surface-to-air missiles on over 1,000 separate occasions, was never hit. The total number of SR-71s built, 32. The number lost to enemy action, 0. The number lost to accidents and mechanical failures, 12. 12 aircraft, no enemy kills. Kelly Johnson received the Collier Trophy in 1964 for the design of the aircraft. He received it again in 1971 for subsequent aeronautical achievements. He died in 1990. He never saw the SR-71 declassified. The full operational history of the SR-71 program was not declassified until 2007. The program that began with 11 engineers in a classified facility in Burbank in November 1959 had outperformed every threat every adversary could produce for nearly 3 decades. It was not defeated. It was defunded. The engineers who built it solved problems that the rest of the aerospace world said could not be solved. They built it in 30 months. They built it from a material purchased covertly from the enemy. They built it so well that 50 years later, nothing flying today goes faster or higher in sustained operational flight. That is the declassified record. If this is the kind of history you want more of, subscribe to History Unclassified. Every video is built from the declassified record, no myths, no filler, just the real story. We will see you in the next one.